We're going to program the ATtiny85 controller using the Arduino IDE so that it can talk to our LED controller and light up each of the ports. First thing I'm going to do is go over to AdaFruit.com and grab some sample code. The AdaFruit page does have quite a bit of documentation that's going to be useful, but the important part here is that we want to be able to test our controller just to see that we can actually program the thing and make it light up the onboard LED. From their site, I'll do a simple cut and paste. And I'll replace the existing code inside of the default sketch in our Arduino IDE with the cut and pasted code and save it, and in this case we'll go ahead and call it Lancer. This sample code doesn't light up our 12-channel controller just yet, but you'll notice the setup function is designed to turn on the onboard LED for the ATtiny85, and then in a loop it's going to turn on that LED, wait a second, and then turn it off again, and then wait another second. Before we can compile this firmware and send it over the microwave USB cable to our ATtiny, we have to select the correct board to compile it for, in this case, AdaFruit Trinket ATtiny85 at 8 MHz. And then we have to select the programmer that we're going to use to send it over the wire. In the same menu, we can find a programmer called USB Tiny ISP, and just select that one. To program an AdaFruit Trinket, we actually have to put it into USB serial flashing mode first. Disconnect your board, and then when you plug it into your computer via USB, you'll notice the status LED will begin glowing for about 10 seconds. At that point, you can hit the flash button, which is the arrow in the upper left corner. After it uploads our firmware, you'll notice that it resets and begins running our program. In this case, blinking the LED on and off at 1-second intervals. To get our ATtiny to talk to the LED controller, I'm going to download a library off of the internet. In this case, I'm not using AdaFruit's library, but a different one by a guy named Ulrich Stern. This library provides us some nice convenience classes for interacting with the 12-channel LED controller so that we don't have to program the binary language that controls it ourselves. Using this library, we're going to set each of the 12 channels of the PWM LED controller to output at maximum brightness. Unfortunately, I had to do some hacking to get this library to compile for the ATtiny85. That's simply because the 85 doesn't support all of the features of an Arduino 328P, specifically the way in which it interacts with what's called the serial programmable interface, which were those 3 wires that are connected in between the ATtiny85 and the PWM LED controller. Once I've gotten my firmware to compile, I can go ahead and put the ATtiny85 back into serial programming mode and then flash the firmware again. I can use a multimeter to confirm that each of the pins onboard the LED controller does put out a 5-volt signal, which is kind of the end goal here. By touching the red and black probes to one of the positive and corresponding grounds for the LED ports, I can confirm that this controller does in fact work, and it is receiving the correct instructions from the ATtiny85, in this case to put out a 5-volt maximum brightness signal. It's putting out a 5-volt signal simply because the power supply that we're feeding into the controller is a 5-volt supply. If it doesn't put out a 5-volt signal, then that usually indicates that I haven't actually correctly connected the LED controller to the ATtiny85. Since I've confirmed that the whole thing works, now I can continue with soldering in LEDs.